Good afternoon, class. This is Pre-Calculus Practice Test 3, Module 3, covering chapters 5, 6, and 7. Here's chapter 7, trigonometric equations and identities. That's what we are going to cover. We want to find the exact value of the expression tan inverse of tan of negative 2 pi over 3. So to do that, let's refresh everyone's memory about inverse functions. Y equals sine inverse x, that means x equals sine y. Remember, none of the trigonometric functions, the way they are given, they have an inverse function. We have to restrict the domain. So what happens, in the case of a y equals sine x, we restricted the domain from negative pi over 2 to pi over 2, which becomes the range for the inverse. And of course, as you remember, the range of sine is from negative 1 to 1, which becomes the domain here. That's how we make it happen. So when we look at their composite function, it's x as long as x is between negative pi over 2 and pi over 2. Sine inverse of sine x is x. But if it's sine of sine inverse of x, this x must be between negative 1 and 1 for it to work. So just to give you an idea, and when we understand sine, the rest of them becomes fairly simple. Tan inverse, the only reason I go with tan inverse first, because the restriction that we put for sine, we have the same thing for tangent, except it doesn't have an equality. For cosine, the restriction, we put the restriction from 0 to pi on cosine for it to work. So if x is between 0 and pi, cosine inverse of cosine x becomes x. And if x is between negative 1 and 1, cosine of cosine inverse becomes x. Because this is the one that matters. Remember, for cosine inverse, x has to be between negative 1 and 1. And so with that being the case, cosecant basically follows sine. Secant follows cosine. Cotangent follows cosine. Those are the concepts that, as far as the inverse functions are concerned, and I want to make sure that we are okay with that. So with that being the case, negative 2 pi over 3 puts us in the third quadrant, and it becomes the same as tan of pi over 3, because in the third quadrant, tangent is positive. And tan of pi over 3, we know it to be square root of 3. So we want tan inverse of square root of 3, and therefore the answer is pi over 3. Again, understanding the inverse functions. Secant inverse of square root of 2. Whenever we are given a case like this, I like to set this equal to some variable, alpha, beta, gamma, x, you name it. For example, if this is alpha, by definition, means secant of alpha is square root of 2. And because we are familiar with cosine, cosine is the reciprocal of that. Let's go with the cosine. Cosine is 1 over square root of 2. Or square root of 2 over 2. And you know alpha to be pi over 4. So again, we go from secant to cosine because it makes it easier to come up with the answer. Cosine inverse of 1/2. Again, we set it equal to something. And since I don't want to repeat the alpha, although I can, it's a different part. I'm going to say theta. By definition, cosine theta makes it 1/2. And as you know, cosine theta is 1/2. That means theta is pi over 3. Again, knowing the common arcs. Tan of cosine inverse of square root of 3 over 2. First, we want to discuss this part. So what is this equal to? What is this? We're going to set it equal to some variable. Again, something different. Let it be like beta by definition. Then cosine of beta becomes square root of 3 over 2. and beta becomes pi over 6. So what we are looking at is tan of pi over 6. And we know tan of pi over 6 to be square root of 3 over 3. Tan of pi over 6. Cosine of inverse of 1.2. If you don't know it, you can set this equal to alpha and say cosine of alpha is 1.2. As you know, cosine is between -1 and 1. So this is undefined, and the reason is because 1.2 is larger than 1. You can go with this one, for example, and say x must be between -1 and 1. Or you might do this, say, this is x, let's say. I don't want to use alpha, it's already used. And by definition, cosine x equals 1.2, and this can't be, has no solutions, okay, because it's between -1 and 1. All right. Find the exact value for cosine of sine inverse of -1/3. So what is sine inverse of -1/3? It represents an arc. So let's say it's cosine of alpha, beta, gamma, theta, whatever you want to call that. Okay, so if we let theta represent that, that means we are interested in cosine of theta. So let's find theta and plug it in. So by this definition, sine theta must be -1/3. And -1/3, because sine, the restriction was that we are in the fourth quadrant to the first quadrant, and sine is negative, must be quadrant 4. And the idea is ultimately we know that in quadrant 4 cosine has what sine, that's why, okay, which is positive. So we can use, again, we are using unit circle and triangles. I'm going to approach it two different ways. And so because sine theta is -1/3 or y over r, r can't be negative, r is 3, so y must be -1. And we can calculate x to be 2 square root of 2, and the reason why is very simple. X squared plus y squared equals r squared. Class, because x squared plus y squared equals r squared. And so with that being the case, I'm showing you the drawing. We have the x coordinate missing. We have the y coordinate being -1. We have r being 3, x squared plus y squared equals 9. The reason why, because it's x squared plus y squared equals r squared. And we get 2 square root of 2. I hope you understand. You square this one. And you square this one and you subtract from it. So 9 minus 1 becomes 8. So x squared is 8. Maybe I write this. X squared is 8. And x becomes plus minus 2 square root of 2. And we take it to be positive in the fourth quadrant. And therefore, we are going to write x over r. X, 2 square root of 2 over r. That's the answer. If we want to go with the identities, where sine is -1/3 and cosine is plus minus the square root of, this is Pythagorean identities, remember, sine squared and cosine squared is 1. So sine is -1/3, it's in quadrant 4, cosine is plus minus the square root of 1 minus sine squared theta, and cosine is positive, so we go with the positive. So just the plus sign, 1 minus this 1 to the second power. And this becomes 1 over 9. So 1 minus that is 8 over 9. And square root of 8 over 9 is square root of 8, or 2 square root of 2 over square root of 9, or 3. So the same answer. And again, two different approaches. I don't know which one is easier for you, but you have to be exposed and comfortable with both. Write a trigonometric expression sine of tan inverse of u as an algebraic expression. And we remember that if theta is tan inverse of u, by definition, u becomes tan of theta. And u can be between negative to positive infinity, but theta between minus pi over 2 and pi over 2, the restriction we put because to make it a one-to-one function having an inverse. And so we can say tan inverse of u is theta, tan of theta is u, and we are interested in what? Sine of theta. So a couple of different ways to approach that. One easy way, we know that the Pythagorean identity, right? 1 plus cotangent squared is cosecant squared theta. Cotangent is 1 over u, by the way. And sine is a question mark. Because of the Pythagorean identity, we can use that. And so 1 plus, now this one squared, you get 1 over u squared. And if you take a common denominator, you get u squared plus 1 over u squared. And that is cosecant squared. Cosecant squared. Sine is 1 over cosecant, or cosecant is 1 over sine. They are reciprocal of each other. Therefore, sine squared is the same thing, flip it over. That means u squared over u squared plus 1. So from here, this is cosecant squared. The reciprocal is sine squared because of the relationship between sine and cosecant. Cosecant is 1 over sine. That's why. And so sine is plus minus the square root of that. And you use the positive version because sine and tangent have the same sign. Why is that? Because both of them are in the fourth or first quadrant. So in the first quadrant, both of them positive. In the fourth quadrant, both of them negative. Okay. Let's look at a different approach. So when we go back here, tan theta is u. And tan theta is the opposite over adjacent. So u over 1 the opposite over the adjacent. If you remember, the opposite over the hypotenuse, for example, is sine, right? Okay. Or the adjacent over the hypotenuse is the cosine. So this is theta. So you draw it. It doesn't have to be to scale. You draw it any triangle that you want. Here's theta. The opposite is u, and this is 1. So you can calculate this using Pythagorean theorem. Square this one, add them up, the square root of that. That would be the question mark, right? And what is the sine? The opposite over the hypotenuse, u over this. And I guess it's a lot faster if you use a right triangle. It is absolutely up to you what you want to do. Let's look at some trig identities and therefore be able to handle, proving identities, solving equations. For example, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And if you have a negative, we have a negative here. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And if we have a negative here, it changes to positive. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. And if you have a negative, just change this to negative and ends up being here. So a lot of identities that we are supposed to know, class, in order to move on. For example, sine of 2 alpha, okay? 2 sine alpha, cosine alpha. Cosine of 2 alpha, we have 3 different ways of writing it. Cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1. And basically, it comes from Pythagorean identity to change, use the Pythagorean identity to either get rid of cosine squared or sine squared. Tan of 2 alpha, all you have to do here, put another alpha, and it proves tan of 2 alpha is 2 tan alpha over 1 minus tan squared alpha. You're not responsible for the proof, but if you remember, it helps you. In case you forget something, you can easily prove that tan of 2 alpha is 2 tan alpha over 1 minus tan squared. So sine squared is 1 minus cosine 2 alpha. So if you look at this, okay, in this case, you can solve for sine squared, you get 1 minus cosine 2 alpha over 2. And if you cut this in half, you cut this in half, and you get this formula. And for this formula, cosine 2 alpha is 2 cosine squared alpha minus 1. You can solve for this formula. And if you cut this in half, you cut this in half. Again, I'm showing you how the formulas work out. And of course, tan squared of alpha is 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. If you cut this in half, you get this one. And all of this, you just take a root. Take a root, you get the following. So there are a lot of formulas here, and we're going to use them for the identities. For example, in this case, we don't want to use a calculator, and we want to come up with sine of 195 degrees. So use a half angle. We write sine of 390 over 2. And by the way, because 390 class is 360 plus 30, it makes it a common arc. You don't need a calculator. So with that being the case, I can use this formula, plus minus the square root of 1 minus cosine of 390 over 2. And whether it's positive or negative, we go back and look at this one. Remember, this is 180 plus 15. That gives us the third quadrant, in which case sine is negative. So let me make sure that you understand this means quadrant 3. Therefore, it's negative. So we keep the negative sign. And as you know, as I mentioned, this is 360 plus 30, and so it's the same as 30 degrees. Cosine of 30, you know it to be square root of 3 over 2. And now, if I multiply this one by 2 and this one by 2, what happens? This one becomes 4, comes out as 2. And this one, 2 times 1 is 2, this goes away. So square root of 2 minus square root of 3 over 2. This is the precise answer. Okay. I want cosine of 15 degrees. It's the same as 30 over 2. By the way, there are other ways. For example, you can write 45 minus 30 and do it that way when it's, want to do that. But for now, 30 over 2. And again, we go with this plus minus. And this is the first quadrant. Clearly, cosine is positive. This makes it quadrant 1. Quadrant 1, everything is positive. And you replace cosine 30 again with square root of 3 over 2. And again, you multiply this one by 2. You multiply this one by 2. The bottom comes out as 2. And the top is very similar to what you had, with the exception this was minus, this is plus. And as I said, you can try this one. I highly recommend you do it, so you'll be exposed to various methodologies. And we want to prove this identity, secant 2 theta is secant squared theta over 2 minus secant squared 2 theta. Remember, when you want to prove identities, you want to go from one side to the next. And generally speaking, you start with the more complicated side. As you can see, the right-hand side is more complicated. And we can change the secant to 1 over cosine. So this becomes 1 over cosine squared, so on and so forth. Now, this is a complex fraction, and you multiply the top and the bottom by cosine squared theta, which is the LCD. And it makes the top just come out as 1, and the bottom 2 times that minus 1. Now you may recognize this as cosine 2 theta. right? Cosine 2 theta based on the formulas that were discussed, cosine of 2 alpha. This is extremely important. There are many different ways of writing, but you really need to know all of them. Cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1. And therefore, it's 1 over cosine 2 theta or secant 2 theta. We want to prove this. We start from one side. For example, if we start with the left-hand side, we can factor the numerator. This uses a cubed minus b cubed, which is a minus b, a squared plus ab plus b squared. If we had a cubed plus here would be plus here minus here, okay? So that's how we get to what we see here. Now we can drop these two and write the rest of it. As you can see, these two add up to 1. And that's the proof. Sine 3 theta is 1/2. Theta is between 0 and 2 pi. We want to find the answers. And I want to go over the methodology for that. First and foremost, ignore the 3 theta. Imagine it's x. So sine x is 1/2. And from 0 to 2 pi, there are two answers, pi over 6 and 5 pi over 6. And x is 3 theta. By the way, I hope you know that this is pi over 6. And then this is pi minus pi over 6 because pi over 6 is the reference arc and sine is positive in the first. Sine is positive here, okay? So in the first quadrant is pi over 6. In the second quadrant, pi minus pi over 6, okay? So x is 3 theta. How do we do that? Whenever you have multiple angles, 2 theta, 3 theta, 4 theta, this is the methodology that I'm going to show you. So 3 theta equals pi over 6. And you must write it as 3 theta equals pi over 6 plus 2n pi. Now, since we're solving for theta, we're going to divide by 3. This becomes pi over 18. This becomes 2n pi over 6 over 3. Now, we are going to replace the n. We're going to replace the n with 0, 1, 2. How far do you go? 1 less than this number, okay? So if I plug in 0, I get pi over 8. If I plug in 1, I get 2 pi over 3 plus pi over 18, which is 13 pi over 18. If I replace it with 2, I get 4 pi over 3 plus pi over 18, which is 25 pi over 18. So both of them we write them in this format. And both of them we divide by 3. This is 5 pi over 18. Now again, in all cases, n is what? 0, 1, 2. How far do you go? You go to the 1 less. What if I use the next number 3? Okay. So if you use the next number 3, let's see what happens. N cancels out the 3, right? You get 2 pi. So it's a complete revolution. You go beyond 0 to 2 pi. Again, if you use number 3 here, 3 cancels out 3. It's this plus 2 pi, which is really the same as pi over 8. Now plug in. When n is 0, obviously you get pi over 18. When it's 1, you get 2 pi over 3 plus pi over 18. And so on. The same thing here. When n is 1, you get 5 pi over 18 plus 2 pi over 3. When n is 2, 5 pi over 18 plus 4 pi over 3. So whatever you have has to be less than 2 pi. If it is larger than 2 pi, you've gone way too far. That's why you never go to the next number. All right. We want to solve this equation. Cosine squared minus sine squared plus sine x equal to 0. And we know the Pythagorean identities. Therefore, we are going to use, by the way, when sine squared plus cosine squared is 1, that means sine squared is 1 minus cosine squared, or cosine squared is 1 minus sine squared. So basically, you want to remove one of those and make either this one into sine squared or this one into cosine squared. So if I remove that, I get 1 minus sine squared. And the reason I want to remove that, because this is sine x, by the way. Okay, since this is sine x, I must remove this. And so what we have is 1 plus sine x minus 2 sine squared x. Now, since I want to go with the factoring, I'm going to make this one positive. So I'm going to make this one negative, negative, positive. In other words, I'm going to multiply both sides by negative sign, or I can move them to the right, however you want to write that. And I'm going to put it in descending order so I can easily factor out. You can factor it just the way it is, or you can let sine be, I don't know, let's say y. In this case, you get 2y squared minus y minus 1. If you go with that and you factor that, but so we have y and 2y, and since this is negative 1, it's just the product of 1 and negative 1. So this is plus 1, this is minus 1. You have to make sure that these 2 and these 2, when you put them up, you get the middle term. Or just factor it in this format. You don't have to waste your time that way. So 2 sine x plus 1 times sine x minus 1. You said this one equal to 0. You said this one equal to 0. So this one gives you negative 1/2, and this one gives you positive 1. Now, if it were 1/2, if sine, anytime you want to solve this, what do? Sine x equals 1/2. X is pi over 6. This is your reference. Theta r, okay, reference arc theta r. Because it's negative, sine is negative in the third quadrant and in the fourth quadrant. In the third quadrant, you add pi over 6 to pi, you get 7 pi over 6. In the fourth quadrant, subtract from 2 pi, you get 11 pi over 6. So just to make sure, again, how do we get this? Pi plus pi over 6. How do we get this? 2 pi minus pi over 6. And sine is 1 when x is pi over 2. So we have those answers. Prove the identities, and I'm going to remind everybody of sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. If it's negative, we're going to get a negative here. Cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So we are going to use this one, where alpha is pi over 2, beta is x. So cosine of pi over 2, according to that, cosine of pi over 2, cosine x, minus sine of pi over 2, sine x. You know cosine of pi over 2 is 0, sine of pi over 2 is 1. right? So you get negative sine x. Tan theta over secant theta is sine theta. So let's look at the left side and replace the tangent with sine over cosine and secant with 1 over cosine. And obviously, all you have to do just drop this, right? Or just multiply by cosine theta over cosine theta, either way. And the answer is sine theta. It's a very simple proof, everybody. You want to prove this one. Cosine to the power of 4 minus sine to the power of 4 is cosine 2 theta. So we start from one side. The left-hand side is more interesting, okay, more complicated. So you can see that a squared minus b squared is a plus b times a minus b. So you can say cosine squared plus sine squared times cosine squared minus sine squared. So this is a squared minus b squared equals a plus b, a minus b. That's what we are doing. Needless to say, everybody knows this is 1, right? And so you get cosine squared minus sine squared. And as you know, that is cosine of 2 theta. And believe it or not, that's the proof. We want to prove tan x over 1 plus tan squared is sine x cosine x. We start with the left-hand side. And on the left-hand side, the denominator is secant squared class, right? Because 1 plus tan squared is secant squared is one of those Pythagorean identities. Now, the top, we change it to sine over cosine, and the bottom is 1 over cosine squared or 1 over cosine to the second power, either way. And so if you multiply the top and the bottom by cosine squared, which is the LCD, what happens is that these two cancel each other, and these two, one of the cosine goes away, you get sine x times cosine x, and believe it or not, that's the proof. We want to find the exact value, and we notice that sine to alpha is 2 sine alpha cosine alpha. So 2 sine alpha cosine alpha is sine of 2 alpha. So sine of 2 times pi over 8, which makes it pi over 4. And you know that sine of pi over 4 is square root of 2 over 2. Same formula. This is 2 sine alpha cosine alpha. So sine of 2 times 45 degrees, which makes it 90 degrees. And sine of 90 degrees is 1. We want to come up with the exact answer. We notice that 7 pi over 12 is 3 pi over 12 plus 4 pi over 12. And 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3, both of which are common arcs. And we can use cosine of alpha plus beta. So cosine of pi over 4, cosine of pi over 3 minus sine of pi over 4, sine of pi over 3. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is 1/2 minus sine of pi over 4 is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. And as you can see, the denominator is 4 for both cases, so 4. So this is square root of 2 minus square root of 6 in the numerator. And remember, both of them have the same common denominator of 4. Find the exact value. Again, we may notice that this follows the formulas here. Cosine of alpha plus beta, cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So put this next to this bottom one. And so that means cosine of alpha minus beta, cosine of pi over 12 minus 5 pi over 12. And by the way, it doesn't matter which one you put first. Makes no difference. You'll see in a moment. I'll show you why. So whether you put 5 pi over 12 minus pi over 12 or vice versa, makes no difference. This is minus 4 pi over 12, which means cosine of negative pi over 3. Cosine is an even function, so it's the same as cosine of pi over 3, and that's 1/2. That's why I said makes no difference. You put positive or negative, it doesn't make any difference. Cosine of 105, and I hope you recognize you can make this a common arc of 90 plus 60 plus 45. And so now you can use this formula. Cosine of 60 cosine of 45 minus sine 60 sine 45. Also, you can say 150 minus 45. You can try that. 150 minus 45. That's the same thing. All right. Cosine of 60 is 1/2. This is square root of 2 over 2 minus sine of 60 is square root of 3 over 2. This is again square root of 2 over 2. And both of them have the same denominator of 4. So it's square root of 2 minus square root of 6 in the numerator. Denominator is fixed, as I mentioned, at 4. Sine 50 cosine 10 plus cosine 50 sine 10. We notice it follows sine of alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. So this is sine of 50 plus 10, which makes it sine of 60 or square root of 3 over 2. I hope you recognize the importance of knowing the formulas. Okay. Sine of 165. You can say sine of 120 plus 45 because both of them are common arcs. So you follow the same formula. Sine of 120 cosine of 45 plus cosine of 120 sine of 45. And remember, 120 is in the second quadrant where sine is positive. So sine of 120 is the same as sine of 60, okay? So makes it square root of 3 over 2, and cosine is square root of 2 over 2. Cosine, again, 60, but minus cosine 60. Why minus? Because in the second quadrant, cosine is negative. Cosine is negative. So this one is minus 1/2 times square root of 2 over 2. So again, the denominator, 4 here, 4 here. So this is square root of 6 plus, and then this makes it negative, minus square root of 2 in the numerator. We want to prove the identities, and ln of this plus ln of that equal to 0. I'm going to remind you of how we put them together. The product rule, if you recall, ln of x, y is ln x plus ln y. So if I want to go this route, this becomes ln of the product of these two pieces, which is secant squared minus tan squared. Now, this is equal to 1. Why is that? Pythagorean identities. Recall, sine squared plus cosine squared is 1. 1 plus tan squared is secant squared. 1 plus cotangent squared is cosecant squared. So if you stick with the second one, secant squared minus tan squared. must be 1. And ln of 1 is 0. I hope you know ln of 1 is 0. All right, we want to prove sine theta plus cosine theta quantity squared plus sine theta minus cosine theta quantity squared is true. We start with the more complicated side, which is the left-hand side, and we're going to square each case. This becomes sine squared plus 2 sine theta cosine theta plus cosine squared plus we square this one, which is sine squared minus 2 sine theta cosine theta plus cosine squared theta. And these two cancel each other. So we have two of these. So each one, so factor the 2 out. And this is 1, 2 times 1 is 2. Very simple, everybody. Two cosine theta minus square root of 3 equal to 0. And we want to answer from 0 to 2 pi. It's very straightforward. So 2 cosine theta is square root of 3. Cosine theta is square root of 3 over 2. And between 0 to 2 pi, it's pi over 6 or 11 pi over 6. I hope you know why. When it's square root of 3 over 2, the answer is pi over 6 in the first quadrant. Cosine is positive in the fourth quadrant. So 2 pi minus pi over 6, that would be the answers. And if they ask for the general solution, all coterminal angles, if the terminology is, you add 2k pi or 2n pi, depending on the text they use, 2k pi or 2n pi. Same thing plus 2k pi, same thing plus 2k pi, or 2n pi, as I mentioned. We want to solve this equation, and we just have seen this. It's just a simple factoring. I hope you can do it just the way it is. So I'm going to factor it into that. If you have a difficult time with that, you can say this is, let's say, x, and therefore this is this 2x squared. And now factor it. Either way is fine. So either cosine theta is either 2 cosine theta plus 1 is 0 or cosine theta minus 1 is 0. And the first one gives us cosine theta is equal to negative 1/2. The second one, cosine theta equals to 1. Again, this one, I want to make sure we understand what's happening. If cosine theta was 1/2, then theta would be pi over 3. This is really theta r, the reference arc. Are you with me? And so, since it's negative 1/2, cosine is negative in the second quadrant. So pi minus pi over 3. And in the third quadrant, pi plus pi over 3. And this one, of course, theta is 0. So pi minus pi over 3. Maybe I write it here like this. So this one is pi minus pi over 3. And this one is pi plus pi over 3. Okay. That's how we arrive at the answer. You should be very comfortable with that. So you write all those answers. We want to find the exact value of the expression, 1 minus cosine squared 20 minus cosine squared 70. And you may recognize this one as a sine squared 20, right? Sine squared 20. And cosine of 70, okay, there are co-functions or complementary angles I want to discuss. Sine of pi over 2 minus a is cosine of alpha. Cosine of pi over 2 minus alpha is sine alpha. Tan of pi over 2 minus alpha is cotangent alpha. Cotangent of pi over 2 minus alpha is tan of alpha. In other words, if you look at a triangular shape, just for the sake of argument, a right triangle in general, the concept is as follows. This angle and this angle, they add up to 90 degrees. So sine of one is cosine of the other. That's the concept. And with that being the case, for example, cosine of 70 is the same as sine of 20, okay? 90 minus 70. So we replace this with sine squared 20 and it becomes 0. So again, as long as the two numbers add up to 90 degrees, sine is the same as cosine of the other one. For the sake of argument, so you see what I'm talking about here. As an example, sine of, let's say, 31 degrees is the same as cosine of what? You subtract 31 from 90. It gives you 59 degrees. In other words, if these two add up to 90 degrees, sine of one is cosine of the other. And why? Because sine and cosine are considered co-functions of complementary angles. Remember, means they add up to 90 degrees. All right, so when we look at this one, it's the cosine of alpha plus beta, so 70 plus 20. Right, cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So what we have is cosine of 70 plus 20, which makes it cosine of 90. And cosine of 90, we know it to be 0. Tan of 20 plus tan of 25 over 1 minus tan 20 times tan 25. I'm going to remind you of the tan of alpha plus beta having the same formula. So this is tan of alpha plus beta, 20 plus 25. Now this is tan of 45 degrees, and you know it to be 1. Very straightforward, everybody. We want to find the exact answer. And it's important to know this represents an angle. So if you set this one equal to alpha, this one equal to beta, let's see what happens. If this is alpha, by definition, cosine alpha is 1/2. Remember, it's from 0 to pi. And if you say this is beta, then sine beta is 3/5. And that goes from negative power to the power 2. So what you're looking for is sine of alpha plus beta. And as you know, sine of alpha plus beta has this formula, sine alpha cosine beta plus cosine alpha sine beta. And since we have cosine alpha and sine beta, over here we want to find sine alpha. Over here we want to say find cosine beta, and then we plug it in. Sine squared plus cosine squared equals 1. That will help us find sine alpha. Square root of 1, square root of 1 minus cosine squared theta. Uh, 3/4 or square root of 3/2. Remember, it's in the first and second quadrant, and sine is positive in both. For cosine beta, cosine is square root of 1 minus sine squared, square root of 1 minus sine squared, and that is 3 squared, which is 9/5 squared, which is 25. So 16/25 comes out as 4/5. Now, as far as the sine is concerned, it's in the fourth quadrant and the first quadrant, in which case cosine is positive. That's why both numbers are positive. Now plug in. Square root of 3/2, square root of 3/2 times cosine alpha, which is 4/5, cosine beta, cosine alpha, which is 1/2, times sine beta, which is 3/5. Both of them have the denominator of 10. This has 4 square root of 3. This has 3. We put them at top, and this is an exact answer, class. We want to establish the identity. The left side, tan theta plus cosine theta over 1 plus sine theta equals secant theta, is more complicated. So we start with the left-hand side, and we write this one as sine over cosine. We take a common denominator of cosine times 1 plus sine. So sine theta times this gives us sine theta plus sine squared, and this one gives us cosine squared. And as you can see, so again, we are taking a common denominator. We add them up. These two add up to 1. Sine theta plus 1 is the same as 1 plus sine theta. They are the same. If you cross them, becomes 1 over cosine theta, which is secant theta. And that's the proof. We want to prove this again. The left-hand side, LHS, left-hand side is more complicated. We are going to take a common denominator of sine theta times cosine theta. So sine 3 theta times cosine theta minus cosine 3 theta times sine theta. So what was sine of alpha minus beta? Sine alpha cosine beta minus cosine alpha sine beta. Take a look at this one. Therefore, the numerator is sine of alpha minus beta. So sine of 3 theta minus theta. And the bottom, I hope you recognize, according to this, it's half of that and makes it half of sine 2 theta, right? Half of this. So the top is sine of 2 theta. The bottom is half of that. And therefore, the answer is positive 2. Understand this half of sine 2 theta. They cancel each other. 1 over 1/2 is 2. Again, the left-hand side, 1 minus sine squared over 1 minus cosine theta equals negative cosine theta. The left-hand side is more complicated. We start with the left-hand side. There may be other approaches, but a very fast and easy approach would be to write this as 1 minus cosine squared. So write this as 1 minus cosine squared. And you know this is 1 minus cosine, 1 plus cosine. So 1 minus 1 plus cosine. And so 1 minus 1 minus cosine. Okay, so if you apply the negative, we get minus 1 minus cosine. And this is the end of the proof. The second methodology is to take a common denominator of 1 minus cosine theta. So we get 1 times 1 minus cosine theta. We can do it this way too. As you can see, these two cancel each other. And we can factor the cosine theta out from what is left. It's cosine squared minus cosine theta. Factor out the cosine theta. And I hope you realize these two are not identical. They are opposite. So one cancels the other, but it produces a negative sign, minus cosine theta. I showed you both methods because sometimes there are different methods, and which one is easier, ultimately, it's your choice. Again, the left-hand side is more complicated. So let's do the math. By taking a common denominator, multiply this one by this one, minus you multiply this one by this one, sine theta, cosine theta, or cosine theta, sine theta is your common denominator. So this gives you sine theta, cosine theta, plus cosine squared, minus sine theta, cosine theta, minus and minus, plus sine squared theta. I'm assuming at this level, we can easily handle that. So what happens is sine theta cosine theta, and this one, they cancel each other, right? And the numerator is cosine squared plus sine squared. As you know, they add up to 1. And you can write this 1 over cosine, 1 over sine, which makes it secant theta, cosecant theta. We want to establish the identity, and there are different ways of approaching it. We know the sine to alpha is 2 sine alpha cosine alpha, and cosine to alpha is that. So starting with the left-hand side, this is a sine of 2 times 2 theta. So if you think 2 theta is your alpha, if you will, so it becomes a 2 times sine of 2 theta. Think about this maybe as beta, okay, or even alpha. So sine of 2 alpha, 2 sine alpha cosine alpha. So 2 sine of 2 theta cosine 2 theta. Now, this one is 2 sine theta cosine theta. And since over here, we have cosine theta times 8 sine cube times 4 sine theta minus 8 sine cube, we can write this as 1 minus 2 sine squared. Instead of theta, we're going to use alpha. Now, of course, we have 4 sine theta cosine theta here, 4 sine theta cosine theta. So if I take the cosine theta out, this is 4 sine theta times this part. Because remember, I want to make it look like that. So I have the cosine theta. If I put the 4 sine theta in by multiplication, I get 4 sine theta minus 8 sine cubed. And I'm done. Okay. Again, this is one way to do it. There may be other ways, but this is one way to handle it. Use the product to sum formula to fill in the blanks in the identity below. Sine of 14x, cosine of 6x. We want to write it like this. So we have, I'll put 3 formulas for you: sine alpha, sine beta, cosine alpha, cosine beta, and sine alpha, sine alpha, cosine beta. So for one of them, we put alpha plus beta, 14x and 6x. For the other one, we want alpha minus beta, 14x minus 6x. And it depends how they want it. Okay, sometimes they might say the first one put the smaller one, or might say the first one put the bigger one. But this is the formula that you're using, and you want to answer it accordingly.